Today we're going to go over how to use Excel to create a titration curve. So before we get going, we need to remember which variable is graphed on which axis. So the independent variable is what is changed or controlled during the experiment. So during your experiment, you controlled the amount of base added from the burette. The independent variable is always graphed on the x-axis, and the data for the independent variable should be in column A. The dependent variable is what you measure. So you were measuring the pH. pH will be graphed along the y-axis, and the data for the pH for our dependent variable should be in column B. So once you have your data entered, you can highlight it, and we want to go to Insert, and we want to enter a scatter plot with smooth lines and markers. Once you insert your graph, you can see that it's missing axis titles, so we want to add those back in. The way we can do that is by going to the top left and click on Add Chart Element. You can then add axis titles for both the X and the Y axis. Be sure to give your graph a title. And we also want to change the name of those axis titles you just added. So remember, the x-axis is the independent variable, and you controlled the amount of potassium hydroxide added. And we also want to make sure that we include units in parentheses. So that would be milliliters. The y-axis is your dependent variable, what you were measuring, which was the pH. So you should be able to use your titration curve to determine the equivalence point. But looking at our graph, it's really hard to estimate since the amount of KOH, amount of our potassium hydroxide, goes up in 5 milliliter increments. So what you can do to fix that is we can right-click on the numbers along the x-axis and go to Format Axis. We can now change it from the major units from 5 to 1. And we can do the same thing by clicking on the numbers along the y-axis and changing it from 2 to 1. So now looking at our titration curve, since this is a titration of a strong acid with a strong base, we know the equivalence point should be approximately at a pH of 7. And you can now determine how many milliliters of potassium hydroxide were needed to completely neutralize the hydrochloric acid.